Hi, friends. Welcome again to another episode of Beyond the Clouds, Edge to Edge Transformation. And very rarely do I get a person who truly works on the edge in edge computing, but has worked in various aspects of technology and has a very kind heart. And one of them is Sanjay. I got to know him in undergraduate school, one of those rare species. Sanjay, tell us about you. How did you become the Sanjay Uppal that we know today? And what was your journey like?
So it's really glad to be here and chatting with you, Shankar. So my journey started, as you pointed out, in undergrad in IIT Bombay, where we were learning about technology. And the thing that always fascinated me over there was how to make things in the electronic domain. So, we had this hobbies club where we would put piece parts together. We had a ham radio system going up, and we also used to watch the skies through our telescope and all of those things kind of towards the edge, whether it was the edge of the universe or it was the edge electronically, have always fascinated me. And so coming out of that, in fact, I remember in the last year of my career, I was working on what now we know as 1G. Of course, at that time, nobody knew 1G would become 5G and now 6G and all this, but it was 1G. This was amps, frequency domain multiplexed mobile radio systems, and I was doing some simulation, and that was absolutely, this mobile phones was fascinating. We didn't actually have a mobile phone at that time, but then coming over to the United States and studying in the University of Wisconsin, Madison, really got to bring together what was happening on the software side to what was happening, way down in frequency modulation and spread spectrum and all of this. My interest in all of this from a communication standpoint continued. So whether it was liberal arts communication, because you remember in IIT Bombay, we also had some of those classes and courses, which I also found fascinating. But then coming over here to Wisconsin, studying the software aspects of it. And then I came to the Valley and, joined when just the building blocks of the internet were being put in place. And what I mean by that is, TCP/IP and what the IETF was doing. We were building the TCP/IP stack that then would be used to run various parts of the internet. It was us, Sun Microsystems, that of course you know very well, and there's Cisco was being born at that time, and these are all building blocks of what became from ARPANET to internet, and then grew from there. And so my career, I think, has paralleled what's happening on the networking software side. And at HP, I did stuff both in enterprise software for businesses, all the way up to the mail layer. So we had this product called HP Open Mail that I thought was very cool. So you could do Microsoft's front end, but people didn't quite trust the Microsoft backend that much, on Windows NT and stuff. So they'd use our Unix-based backends, which I thought was great. But then also network file systems was very good. And then after a while, I went back to Stanford to study management of technology. The most interesting part of that was I actually learned how to hit the ball on the golf course. I'm not good at it, actually. It was actually pretty bad. But HP had the system where they would send promising employees to go study. And then I shifted my career a little bit to the telecom side of the house. Whole new set of acronyms, whole new set of challenges. But even way back then, providing the plumbing for what was then to become the internet as we know it today, the telcos were always looking at how to not be just the plumbing, how to provide more value-added services. And we had come up with these concepts of a software-based broadband controller. And there's a very heady time. This was like 2G, 3G-ish time frame. And then the cable guys were very interested in saying, wait, why do you have to trust this copper that these telcos have put out? How about doing things on broadband cable? And so Time Warner at that time had a couple of fascinating projects. One was to do broadband video. And there was this full service network trial going on in Orlando where they were saying, and of course, today, who goes out and gets DVDs and tapes and stuff, right? Everything's online. But at that time, it was new. You do this broadband video. But then a little less known was this broadband data or broadband internet thing also going on in Time Warner Cable. And it was my group that, along with the folks who were doing the cable modem, that I think built what was either the first or very close to being the first cable modem with the cable modem termination system. And I remember that, way back when there was an old lady in Elmira, New York, where we went to test it. It would work during the day, and in the night when the temperatures fell, it would stop working. And so, getting out there and the front lines of what consumers were facing and then getting the network to work for them. When it did work, she was like, wow, this thing is so fast. It's wonderful. And, those eyes lighting up and getting something like that done, I thought was, really, really a fun, cool thing to make, which has always been the bedrock of my career. It's not been only about how to run a very large business. It's about what are the things that we can do from a technology perspective that can impact the lives of people, everything from the fun end of the spectrum, but also into the more, I'd say, serious end of the spectrum. And by serious end, I mean, very recently here at the startup that I had done just a few years ago was VeloCloud. And this is in the software-defined wide area networking space. And this is to make sure that businesses, when they have large numbers of sites, like, branch offices, they can connect very easily and through multiple underlying networks and get access to the applications that they want. So one specific customer I'm very proud of at the very, like the more important serious end of the spectrum is MD Anderson Cancer Center. When the pandemic hit, what could they do? People have to work out of their homes. Radiologists went home. But if they had a pristine connection from their home, regardless of what the underlying network was, then the work that they were doing could continue. And I have this very good friendship that I made with the person who runs a lot of the IT there. I tell my team, we're not directly saving lives, but we're helping somebody to save lives. So that's at the more serious end of the spectrum. But at the fun end of the spectrum, video streaming, doing things, at home and doing them in a resilient network, that also gives me a lot of joy. But anyway, so I went to HP, and then I was hired by a startup called Webvan. That was the only time in my career where I was actually working for a business to consumer company. And there, essentially what we were doing is delivering fresh produce, tomatoes, meat, and all that to people's homes within a half an hour window of their choosing. This would be very commonplace today, right? I mean, there's DoorDash and there's Safeway, and but at that time, this is 2000, it was not commonplace. This was actually fairly new, fairly unusual. My responsibility was both the network system infrastructure, but also access to Webvan from non-PC devices. Okay, again, edge. It's all edge related. At that time, Cisco, Intel, and a bunch of other people were working on these Wi-Fi screens that we now know as tablets. They're speaker phones or smart speakers with displays. But at that time, putting a non-PC device in your kitchen and ordering from there and having the thing show up within a 30-minute window of your choice was absolutely brand new. And fascinating time, because next to me was the person who ran distribution for Frito-Lay, and there was a guy from GE, and it was just this collection of really smart people, started by Louis Borders of Borders Books, and then George Shaheen comes in from Accenture, and this whole thing is very exciting, goes IPO, many $1 billion of valuation, and then of course the crash hits, and so it goes up like this and it comes down like this, and it literally was the Titanic. But I wouldn't trade that experience for anything. Webvan was a fascinating experience. A lot of bedrock technologies built there, I feel, have found themselves into various aspects of what we've been doing from an industry standpoint. So when I went back home to visit my mom, and she's like, in Hindi, she was saying, okay, so what are you doing now? And I heard you left the big company, HP, and all of this, as I'm working at a company. What do they do? Like, how do I explain this? And then I said, well, you can go to a computer and then you order, and then the tomatoes show up at your door. And she looks at me saying, oh my God, did I send my son all the way to the United States to do what I can do? I just pick up the phone and the tomatoes show up within a half an hour window of my choosing. And so it was like, okay, how do I explain what I'm doing to my mom? But she didn't, of course, realize that at the back end, there was a huge amount of technology. It's not the same thing as calling your shop at the end of the street. But that was a fascinating time. Webvan, it went down. And then I did a series of startups, all in the networking edge sort of space. I did go to India for a couple of years. I was working for a mobile services company, which is another fascinating experience. But when I came back, I started VeloCloud, which was in the software-defined wide area networking space. And essentially what we were saying there, I think, was something very revolutionary. Regardless of where you are, you're at home, you're in the office, you're in a coffee shop, you want access to these applications that are important to you in a secure way, not by knowing all this arcane stuff about what is IPsec and what is not, and how do you switch from one network to the other. It should be seamless to you, like a refrigerator is, right? I mean, you go in, to a refrigerator, you pull your stuff out and everything's fine. The refrigerator works. Why is the network not like that? Why is it that somebody at home has to know what is 192.168.1.1? It doesn't make any sense. And so we put together this system, Ajit Maya and myself and a third person, Stephen Wu. We started this company to do very simple, efficient networking for businesses. And that became VeloCloud. I just happen to have a lot of these little toys on my desk. What previously would take a lot of infrastructure to put in, we put it in one of these little tiny little devices. And this device has a lot of intelligence. It can understand which application is running. It can connect to many networks. It can make the network look seamless. And that was the start of an entire market segment called software-defined wide area networking. And you can think of this as an edge device because it's sitting at close to where endpoints are producing or consuming data. It is simplifying the network for you, but it is not inside a data center. So it's literally living at the edge. And long story short, we got acquired a few years after we started. Other companies got started in the same space. We got acquired by VMware. And then I was at VMware thinking, I might stay here I was trying to think, should I stay here for 6 months, 1 year? The person who actually acquired us, who put it together, his name is Shekhar Iyer, who I think you've spoken with before at the show, another colleague, and he's running Arcus as a CEO right now. And so I go in, become part of VMware. It's actually year 6 right now, would you believe it or not? So obviously I continue to stay, my team continued to grow. And now our vision for the edge has expanded, which kind of brings me to today. So what has happened then is, so this layer that I showed you on this device simplifies the networking underneath. So you could have a broadband network, you could have a fiber network, you could have a wireless network, fixed wireless, and you connect all of them together to this device. And the device actually, in conjunction with the intelligence that sits in the cloud, it forms a network for you at this overlay. And you don't have to worry about whether your broadband is working today or the wireless is working or not. It just hides all of that complexity for you. So beautiful system, whole industry, many people got acquired. But then if you look at what's running underneath, if you look at like what's running in the 5G or what's running in the fiber and all this, and you actually peel the onion, there's a whole infrastructure underneath to run those networks too. And that infrastructure has typically been proprietary, meaning that the hardware, software for that infrastructure is clubbed in together. If you want a feature, then you've got to go back to the people who make that combined device. And it's actually very slow. People know that the cloud and our consumer-based technologies move fast. You get a feature really rapidly. You don't know what's changing in the back end, but telecom, you ask for something and it moves very slowly. You would remember way back when, if you wanted a new line in Mumbai, right? You called up somebody and you said, can I have a phone number? And then 2 years later, you might get it, right? So what we want to do is move at the speed of light. I mean, we're sending these electrons and all that at the speed of light, and we want the connections to come very fast. And so this aspect of software defining something and making it really go fast has permeated into what we call the underlay as well, into the network itself. And so what we're doing right now as part of VMware, and I'll talk about Broadcom in a minute, is really disaggregating the infrastructure that is needed to run a telecom network. And so disaggregating it, meaning you make it much more software defined so that if you want a new feature, then you get that new feature much faster than if you were to go to the hardware provider or the proprietary provider and ask them to add a new feature. There's a whole area about Open RAN and how do you get that done with open APIs, and really bringing what we have come to know very well in the compute cloud side of the house with horizontal stateless architectures that are scalable, bringing that into the telecom side of the house. So my responsibility now is the edge of the telecom network plus the edge of the enterprise network, of which I showed you this device. And then the coolest part now is what is happening in things like the factory floor, in hospitals, energy systems, oil rigs, and just let me touch upon factory floor. So in Barcelona, we have our annual events. The European one happens to be in Barcelona. The North American one happens to be in Las Vegas. So we recently had our annual event in Barcelona. And on stage with us was the person from Audi, the car manufacturer, on stage talking about how they would disaggregate the factory floor. So we talked about disaggregation of the telecom network, making a cell site look like it's just software running on common off-the-shelf platform connected to a bunch of radios. But on the factory floor, and I've visited some of these places where they make these beautiful cars, right? The factory floor is very similar. You have these hardware, software machines. They could be robots, they could be machine builders, they could be even PLCs, right? What we've known as programmable logic controllers, where the hardware software is locked together. If you want a new feature, you go back to the hardware manufacturer, and then you got to wait until this new feature comes out. Then when you want to upgrade, you have a whole new problem because you have thousands of these devices sitting on a factory floor. So the thought process of this very insightful person from Audi, Dr. Henning Loser, was, why don't I separate the hardware and software of these devices on the factory floor, run the software on a stack, and then control the hardware separately. So now if you want a new feature, you upgrade the software, independent cycle from what the hardware is. This, I think, is very cool. And so I'm working at that layer now as part of my business. It's called the Edge Compute Stack. And with this, the promise is if you put that into your factory floor, you can produce cars faster. You can lower the cost of, you can lower the amount of energy because you know exactly what's going on your factory floor. You can bring up, turn down machines as you'd like, reduce the number of defects because it's a lot more automated. So when you put these things together, you have the factory floor, then you have this SD-WAN thing, and then you have the telco network itself. All of this together is what I call living on the edge, right? It's a song by Aerosmith. So it's living on the edge. And I say the other part that you have to remember is this is not about the data center and the cloud. Rolling Stones has another song called Get Off My Cloud. So you get off your cloud, live on the edge, and that's really what the business that I am in at VMware. That brings me to the acquisition of Broadcom. But let me stop here and see if you have any particular question, and then we can talk about Broadcom, which is also very interesting.
Wow, you're literally living on the edge. And I guess you almost answered my question of what's beyond the clouds, and that's the edge.
It's the edge.
You said some very interesting things, and I'm going to ask you questions on that. One is that communication is not just telecom, it's not just bits and bytes going from one end to the other. The purpose of communication at the end of the day is, being heard and being listened to and so on. And you mentioned that in liberal arts or in language capabilities, we have communication, and you're very good at it. I still remember you're a very introspective guy. One of the very few engineers was not fully a geek. He was a geek who could speak. So my question to you is, how valuable has that been in your career? You are dealing with techno geeks who are working on these high-speed communication lines, optical communication, all kinds of communication. And you have this other aspect of you, the ability to communicate well, which you did in the last 10 minutes, explain the whole thing. How valuable has it been in management and leadership and so on?
Absolutely valuable. I think that the communication to me is a continuum. The bits and bytes are just the elements of the communication that we've put into the digital domain. But as you were saying, the purpose of communication is really to bring people together. I mean, if we can communicate more and we can listen and we can understand what other people are saying, I think that in this world and maybe in this universe, a lot of the issues will go away. And I learned this. It's constantly about learning new things. To me, that's a fundamental good in this world, that if you're learning new things, it actually is a good thing. Way back when I was doing that broadband project for Time Warner Cable, the sister division was doing the modem and I was doing all the software and everything. And I went and presented this to the person who used to run a lot of the business at Time Warner Cable. His name was Tim Eward. And there was a technical guy, Mario Vecchi. I explained all this, exciting technology stuff and, in detail. And then Tim says, Sanjay, you know what a duck is? I said, yeah, I know what a duck is. You know what a bunny is? Yeah, I know what a bunny is. He said, tell me what you're saying in ducks and bunnies. And that to me was one of my learning moments, that look, if you can understand all this technology to great detail, it's awesome for you. But can you share your learning with somebody else? In order to share your learning with somebody else, you must put it in the language that they understand. And the language that they'll understand, you over a period of time will learn that in doing communication. And so to me, I've carried that through all the way in my career. And on my desk at work now, there's actually a fluffy duck and a bunny, because someone presented them to me because of the number of times that I used to say ducks and bunnies. Don't come and tell me something that is very, very complicated simplify it into ducks and bunnies, because then not only have I gone through the process of simplifying something and understanding it much better, but then I'm actually able to communicate it to not one person, hundreds, thousands, tens of thousands of people. And if you do that, then you get shared learning. And shared learning is an essential good in this world. The more we can share our learning with other people, I think the more we can advance as a species. So yes, to me, it's inextricably combined. The liberal arts part of communication, the digital communication, the software, to me, is just communication. And that communication happens from endpoints like us, human beings, or from little endpoints like these little devices that we have. And these devices and endpoints sit at the edge. And so all of this kind of makes sense from my perspective.
And I liked how you connected all that with music on the edge and getting off the cloud. Um, Now let's talk in ducks and bunnies now about private 5G. I keep hearing these things. Oh, it's not just 5G. Companies can create private 5G. Is that part of the WAN you're talking about? And also, what's the 6G? Do we really need to go to the 6G? Can you tell us what's happening in all these standards and how things are progressing today?
Yeah, absolutely. It's fascinating that, the 1G stuff that we were working on went to 2, 3, 4, we're actually at 5, which I think is fascinating how it's proceeded along and gotten, faster, more resilient and the like. But I think the private 5G has come in, and there is a problem to solve over there, because when you look at something like going to watch a football game, and you're there, you're watching a football game, and you know what millennials do? They go to watch football games, not for themselves necessarily. Of course, they're watching it, but they also want to share what they're doing with other people. They'll say, hey, I'm at the football game. Look at this touchdown that Brock Purdy has scored. But you can't do that very well with the current network. So what private 5G allows you to do is give you the resiliency and better guarantee that a public 5G network would do, but in a smaller environment. You drive around and you see these massive cell sites. Well, you can't put like 5 massive cell sites in a stadium or in a pop-up retail store. So you have this concept of small cells. So think of a small cell as just a grown-up Wi-Fi router, right? So you put that over there, and then you get much better performance in terms of, figure of merit for radio people is how many bits can you send with good resiliency for every hertz that you use, right? So private 5G, it's a better engineered solution from a resiliency perspective, from its efficient use of bandwidth. And so you get a better connection in the parts that you would ordinarily not expect to. So inside a factory floor, in your basement, in a stadium, in an agricultural field where Wi-Fi doesn't do very well. So it's just a better way of doing Wi-Fi. Now, it doesn't have to be one or the other, which is the value that SD-WAN brings. So you can have private 5G, you can have Wi-Fi, and then if there was software to decide for you, hey, I'll use the best networks, or I might use all of them and combine them together. How about that? If you were to combine the best of private 5G and the best of Wi-Fi for this conversation that we are having, that would be what we would ideally want. Why should you have to choose, oh, I should use this or I should use that one? And so private 5G just fills in yet another type of network. Satellite is another one. A lot of interest now in satellite. After Starlink came in, Hughes has come in with a solution. In India, there's another one. And now we know that from Apple iPhones and even from Android devices, you can get connections through the satellite down. So that's yet another connection. But you shouldn't have to worry about saying, oh, should I switch my phone now from 5G or 4G to Wi-Fi? Why do you have to worry about that? You should just want to connect. And so that's the 5G portion of what's happening. Now, 6G, I think the idea is to cure the ills of 5G. And 5G has not quite met all the promises. One of the promises is that was supposed to be is, it's going to open up a whole new way of communication and connection. And it'll be much more, human computer interface oriented. Of course, at that time when it was first being discussed in 3GPP, the concept of doing AI at the edge was still a little bit further away. But now that there's this advent of AI and machine learning all the way down into edge. In fact, I have a collection of little devices on my desk. One of these little devices, in less than 256 kilobytes of RAM, you can put in a machine learning model into these chips that can recognize the movement that you're making. And now, what happens when you wear one of these exercise watches, right? You tell it, I'm going for a run, I'm going for a bike ride, I'm doing weights, you tell it. But why do you have to tell it? What if there was a sensor that actually figured it out for you? You don't have to tell it what you're doing. It'll know what you're doing. Very simple example of using machine learning at the edge. So when you do that, when you have all these possible applications of doing things very far away at the edge, it's going to need a really robust network with that provides you a dynamic network. We don't have that today. This concept of networking on demand, that us networking people, it's the holy grail. It's you ask for a network, but you get exactly what you ask for only for that period of time, and you have the willingness to pay for it, right? We are still doing 100 megabits per second or a gigabit per second. You pay for it on a monthly basis. Sometimes it goes up, sometimes it goes down. You use it not all the time. But if you could just get something that was purely on demand, then that's the promise of what you can get with better frequency usage and all this, which 6G is supposed to get for you. So there's a bunch of things that 5G hasn't solved, which the promise of 6G, get it much more human-oriented, use better spectral efficiency, more bands, get it more edge-oriented. They're just starting to discuss that right now on the 6G spectrum.
Exciting. And I think from what you were saying, things like radiology that is needed from a remote place or getting medical support in remote places is possible with private 5G and a mix of those things and 6G. What about AI on the edge? AI inferencing is obviously happening on the edge, but do you think we'll even be able to train things on the edge? Are there use cases where it can be used today?
Yeah, there's actually an abundance of use cases at the edge. So if you do the normal segmentation and separate predictive AI from generative AI, certainly for predictive AI using machine learning, there are tons of use cases. The simple one, on the factory floor is predictive maintenance, right? So you take one of these devices with a Bosch sensor and you stick it on the side of a machine, and through measurement of temperature, noise, and vibration, it can predict when this machine is going to fail. It's not a formula, it's machine learning. So you collect enough data and you train the sensor, and then the sensor will be able to say. Now, there are an enormous amount of use cases where this machine learning at the edge is possible, and then you can do very clever things with the data that you collect. So it's really about collecting very large streams of data, making sense of them, and not having to go all the way back into the cloud. Another example I'd give you is one of the use cases we were showing in one of our events is the UK Surrey and Sussex police. So, these folks have, just like other police forces, they have cameras in the cars, they're driving around, and these cameras are doing automatic number plate recognition. And I actually sat in one of these cars going on a live police call, right? So I went to London, sat inside the car, I'm sitting at the back, these guys are driving around, they suddenly get a thing saying, okay, head, there's some crime happening at this place. So they, siren goes on and they occupy both sides of the road and they're driving. As they're driving, the cameras are checking number plates and something will flash up on the screen saying, go after that car or don't, or this car is okay or not. Now, as they're driving fast, if that recognition goes all the way to the cloud and comes back, I saw literally in front of my eyes, the car is gone. You can't do anything about it. So this is a classic case of doing machine learning recognition at the edge itself. Now, what if you would take that, expand it into, you're at the crime scene, you want to recognize faces, or they want to throw up a drone and they want to get that feed into the same car and do all of this. So this requires more horsepower, it requires more intelligence. You could conceive of a small enough large language model that you have trained, that you would put inside every one of these cars, which would make it much more intelligent to get you from point A to point B if you were a police officer. Today, it's just shortest path or fastest time or one of these. What's the best way to get there, given that there are these crime scenes happening? Or even for a web van driver, how do I actually get there and avoid these places but go to those places, changing things dynamically? So I've come across now these small large language models or small language models that are much more contained, much more domain specific, can be trained either in the cloud or even at the edge, but then inferencing is done at the edge because the low latency that is required for most of these use cases, you can't afford to go back to the cloud. If you can, you should, because you get much better economies of scale by doing it centrally than bringing it down. But then you lose out on a lot of these types of use cases.
Wow, from ham radios to 5G, 6G, it almost sounds like Star Trek or Star Wars. So
I'm still a
first,
ham radio guy. I
I
still
know,
have a
I can
license.
see that.
I got a beautiful license. You got to apply for the smaller licenses are actually restricted in terms of, the smaller the number of letters and numbers, it's more difficult to get them. Now it's only when someone passes away that you apply for it, and then many people apply. I actually applied for it, and I've never won a lottery in my life, but I got this license that I wanted. It's Kilo 6 Alpha India, K6
Wow.
AI. So it's K6 artificial intelligence. It's like, and K6 means, the 6 means this region of the United States. California and all come under 6. Wisconsin comes under 9. But I'm K6 AI.
Wow, you're still very much going gung-ho on technology. So Sanjay, speaking of changes, there's all this 5G, 6G, and you could be doing it all your life. And then comes the VMware acquisition by Broadcom. How is your life and the life of this technology? How is it going to change? What are the synergies and what are the opportunities in this acquisition?
Yeah, now, it's very interesting. Of course, VMware is not a household name, and I didn't expect it to be. But interestingly, Broadcom is not a household name either. The 15th largest company in the world by market cap. And it's just absolutely a fascinating place. The CEO of Broadcom, of course, is a force of nature, and a person that I feel, not just myself, but a lot of the people at VMware can learn a lot from in terms of his business insights and the way that he runs businesses. But for customers and for employees and everything, I think the opportunity is, but Broadcom fundamentally is a diversified company with a lot of business units that do different things, but many of them do things in the communication space, hence the term Broadcom. And so I think the opportunity is really that, how do you learn? First opportunity is learn from a business model that seems to really work for this company, for shareholders and the like, and how to make sure that we make the right business decisions going forward. I think that far and above is going to be the number one learning for all of us in. And then, if the company is doing well, of course, we expect that we pass along some of the benefit of it down to our customers, employees, and the like. But I think beyond that, and it's too early days to figure out if there are sort of product synergies across, but there are some obvious ones in terms of, the communication, networking, and all that Broadcom works on, and that what we do. Of course, these business units all tend to be fairly autonomous, so we go off and work with everybody out there. But now that there are other companies or other business units within the umbrella, we can work together with them as well. Going forward, what customers can expect is an organization with a higher sense of urgency that is going to deliver our software-defined products to the market. And what's happening within my business unit, which I feel is really exciting, is that it's becoming more autonomous, meaning the sales, the professional services, the carrier-grade support for all of what we spoke about, whether it's 5G or the technologies that will come later, whether it's about the SD-WAN, whether it's about edge compute for manufacturing, the sales of professional services and the support for it is under one umbrella. So then we can talk holistically to customers, solve their problems, I feel, a lot faster. So there's a real sense of optimism. There's also, of course, the nervousness. So it's always a combination of excitement and nervousness when change happens. And so it's my responsibility to bring the human element in, that for our employees who are coming along and being part of this new thing, is to make sure that we carry along the people and help them meet their career goals at the same time that we are meeting the goals of the new company.
When I look at your career, it looks almost like a fairy tale. Little kid tinkering around on ham radios and then going off to build all these devices and then communicating better along the way, learning empathy, learning compassion, and then doing amazing things, going off the cloud all the way to the edge. What advice do you have for people who want to do this kind of technology and have a blend of soft skills and science skills?
When we set up VeloCloud, we got together, Ajit, Steve, and myself, and said, what should the culture of this company be that should reflect what is important to us, what works for us too? And I think there's 3 very simple elements to it that we came up with. One was that, we want to attract people who have a desire to learn new things. And so if you have a desire to learn new things, and find the place that will value that. And it usually happens in places that are trying to make things that have already been done 50, 100 times before, right? So this is one aspect. But in order to do that, once you learn something, I think it's very important that people understand that sharing the learning with other people improves your own learning. There are many very smart people who can learn faster than anyone else, but they're reluctant to share it with other people because they think that other people around them are not as smart as them. And so why should they share it? I try to weed those sorts of people out and try to coach people to say, you can learn faster and better if you share your learning with your peers, with other people, industry. I've seen in my own experience, with the right environment, you can have 4 times the learning than you can if you were just keeping it to yourself. So that's the second aspect that I think is very important, that people, okay, they like something that they want to do, they take the plunge, they learn, and then they share it, they learn much faster. And I think the third thing is the journey is as important or even more important than the destination. If you have fun in the journey, if you're feeding something in your soul that is important to you, and it could be whatever's important to you, right? For me, it's making things are important, but for someone else, it could be something else. If you can feed that and be true to yourself, you'll just feel that I'm doing something that I love doing, and actually I'm getting paid for it. How come? It's like, if you can get to that part, you've achieved whatever you want to get to, I feel, from a career standpoint.
That's wonderful. I've seen people change when they work in the industry. A lot of what we do is very technical, and as you said, communication skills, the soft side of you helps. How have you changed, Sanjay, as a person through all these journeys, 30, 40 years of being in technology and in management? Are you the same Sanjay I knew you from the days when we were doing ham radio and hobby electronics, or has something shifted?
I think some things have changed and some things have remained the same. I think what's remained the same is my love for making things. I think that whether I was back in the IIT hobbies shack making things, or now making things, with software with these little devices, always had that fascination for making things with technology. And I'm very humbled that both my kids actually have gotten some aspect of this making thing within them without any of my pushing or anything. That just happened to love making things as well, which is very gratifying for me to see. On the side that has changed, I feel much better understanding of human nature than I did then. I think we were talking about in engineering school, we were a little bit short on the social end of the stick. I think understanding where other people are coming from, try to be more empathetic, be more patient, and understand where other people are coming from. I think that aspect, I'm always learning. So I think we were collectively as a group at that time, I think we were somewhat brash. Many, many decades later, I feel that some of our rough edges have been sandpapered down either by ourselves or by people around us for the better. For the better. I think we're much more approachable now than we were way back then.
Hopefully, we are maturing, not just getting older. Huh? So,
Exactly. Exactly.
when we were in college, I'm talking about 30 plus years ago, the digital divide was very sharp. Very few people even had a telephone, even in the US, right? Now, it wasn't that common. Forget about all these other devices. Do you think the digital divide is still there and is it changing? What about like education access, healthcare access, water, electricity, everything? What is it doing, all this technology? In what ways is it helping?
If you were to look at Maslow's hierarchy or something like this, and you think of interconnection as being a fundamental right that people have, I think that when I was in India, I was working for a mobile company, and I was just shocked to see that there's so many people who would get all these services from really just feature phones, right? The very simple devices. You send a short code, and you would hear your horoscope for the day, or you would hear Hanuman Chalisa, you would hear the cricket score, or you would hear the latest Bollywood song, or from just pressing short codes or ringback tone people. So there, the bar clearly had changed from when we were, right? We didn't have any of these devices, and people would use them. And just recent trips, so this is 10, 12 years after that, to India, and just the leaps and bounds that society has made in terms of getting people connected is just phenomenal. I think it's phenomenal. I think, of course, in the United States, we've always had the privilege of people, being in the first world and having much better access to technology. But where I think it's somewhat sobering is I don't know if that has truly helped us come together as a race. I think that is the more sort of reflective, maybe more sobering, in some cases more depressing part, right? I mean, if you just think of what's happening and the strife that is going on in the world today, we have all these tools to communicate, but we don't seem to be communicating more. In fact, I think we're communicating less. And the less that we communicate as humans, the more I think there is the opportunity for this strife to continue. So that I think is not that great. But so I think the digital divide from a technology perspective definitely improved, I think, by leaps and bounds in terms of the access, but the use of it for getting humans together, I think, has not improved as much.
I agree with you. In fact, it brings me to the Aerosmith song again, which is Living on the Edge.
Right.
And yeah, more capabilities, more is not necessarily better. We have to find ways to really hone in. So thank you for sharing both the technology side of communication as well as the very human side of communication and how it's making a difference. And may you continue to do that, Sanjay, and to all those who are listening. This is the reason I talk to people, because there's the technology that's moving literally at breakneck speed. We humans are still catching up on the human side of things. We still have wars, we still have calamities, we still have geopolitics, and there is a lot to learn from this. Can we be more human as technology can do all of the other things? We have a lot of growing up to do. And please come forward. I would love to hear your stories. Sanjay, thanks a lot. You give like a half an hour tutorial on some of the latest widgets and gadgets and how it can help us be more human. Thank you.
Great chatting with you. Thanks for the opportunity.